sorry, around 80 only, right? So that's the reason we are just imputing. So you can see here, we're just imputing the self-employed with corresponding most frequent value we had in this column. Similarly, the city, we are just taking consideration for the mean value. So then it going imputing these distances. And the last transaction, we don't have any data. For that, we don't know whenever some person has a last transaction. So further, we just giving the dummy variable for the 999. So in this case, why we take as a 999? So we don't know about the dummy variable at the end. So if you just give it as a zero, so that does not make sense at all. If you give as something other dummy variable as a year, that will be very good. Eventually, all the people will try out with the 999 or 444. That is eventually works out. Even in my current project, also we are doing with the 999. Okay, so the data pre-processing with corresponding to our logistic regression. Obviously, the data pre-processing consists of the standard scalar. So whenever we do column standardization, that means future scaling, it will be works better if you directly apply the logistic regression. And somehow you can also reduce future integrity or future importance to get data from. So let's do that pre-processing steps what we had. And the occupation wise, it is a categorical variable. Just we have to convert to the somehow numerical wise. So what will happen if you just apply the one hot encoding? So this is also one interesting mechanisms if you tried with the categorical variables. So one hot encoding nothing but whenever you have a categorical variable, if suppose you have a categorical variable with the red and color like green and some other color like orange, let's say. So these are the categorical variables in your data set. If you apply the one hot encoding, it will convert as a value to a column wise. That means it will convert F1 red. Whenever you get the value corresponding to the red value, it will become as a 1, and corresponding to the remaining all the values become as a 0. Similarly, it is also create another column with corresponding to the green, F1 green, and whenever you get as a green corresponding to that row wise, it will give as a 1 result. Other than all the values going to be give as a 0 kind of the results. So like that is going to be works out whenever we have active occupation is going to be somehow value. You can say this sample. Okay, so we haven't seen this sample. Okay, so let's also print that sample. Maybe I think we haven't print that sample, but in having some of the values with corresponding to the occupation, it will go and identify with corresponding to the whatever the different values we have. The get dummies is nothing but we're just creating some of the dummies according to our values what we had just seen in this example, red, green, and also the blue like that. So for the numerical, we just apply the standard scalar. This is the best mechanisms to rescaling of data. Okay, then we can also analyze by using whether we have to apply any transformation techniques to rescaling of the data with respect to ordinal or categorical variables. So, yeah, so these are all the numerical columns we had in our data set. We're just taking as a list. We are just looping together to identify by using our lag transformation. Then we can also applying with the standard scalar technique to minimize our linear transformation from non-linear to linear transformation technique. So we are taking and we are merging our data frames. This is a scale data frame we are merging with our categorical data frame, what we just now imputed with the one hot encoding. Okay, so let's go and implement our logistic regression model in this data set after completion of the some of the pre-processing and the missing value imputation. We have so many mechanisms. I can say we are all this skipped out, like outlier detection, some of the missing values to impute with the KNN imputer. But this is a small toy kind of project, I can say, with corresponding to the logistic regression. Okay, so we are taking into consideration of the churn prediction as train target variable, and we are just dropping somehow unused, you can say somehow not that much of usefulness in the modeling perspective, like customer diaries and some of the occupations. So let's build our baseline model corresponding to whatever the columns we had. So these are the columns we are just corresponding to after completion of the standard scalar and also the one hot encoding. So let's define our logistic regression model and train by using without any hyperparameter tuning or anyhow some reducing feature balancing, or you can say forward feature selection or the backward feature selection. We'll come across with that whenever we encounter with some of the feature interpretability showcase. So just train that on how to get the matrix. This is also one of the best matrix I can say, AUC ROC results to train somehow, and it will also give the good results with the corresponding to the TPR and the FPR matrices. So let's take assume something called something score called as 0.7 result. Okay. And similarly, we have seen with this example F1 score. So let's take this example as a 0.7 results according to just for understanding of the logistic regression model. So this is the trained data set, and for the test data set, we are going to be get as around recall. This is a recall matrix around 0.12 result. So this is the 12% we recall. 12% is the false negative results we have. So we have somehow to reduce. This is also one of the good matrix called as a confusion matrix or accuracy results. Yeah, so let's jump on to this something called as cross validation technique. So cross validation technique, it's going to be help us. So whenever you have let's take this example maybe. Yeah, so cross validation technique, whenever you have a large number of the trained data sets, okay, large number of the trained data sets, you just divided into some iteration process. You want to be do some of the iteration process, and you just divided into the trained samples around and also the test samples around. You wanted to keep iterating yourself to minimize the trained samples 80% to 20% or 70% to 30%, like that. So if you're going to be try with threefold cross validation technique, it will keep iterating the 3 times with according to the trained samples and also the test samples. And whenever you tried with somehow with 70% or 30%, it will keep iterating with somehow reducing the test samples and also the trained samples. Like we just we come across with something called as a cross validation, right? We have not seen the data when we are training somehow the results. You have split it into the train and also the test and also the cross validation. So this is a cross validation results where you haven't done any kind of training results with corresponding to the data points. Obviously this is unseen data points. So whenever you do something called as a k-fold cross validation or stratified cross validation technique, it will keep iterating with regarding the train and the test samples without any doing the cross validation data sets. So we just performing on this data set because we need to identify how does that going to be helpful with the unseen data points. We are getting somehow around the results around 0.7, but how does that going to be help us in the cross validation data sets? So currently we are using k-fold cross validation technique with 5-fold. So it will keep iterating with the 5 and the 5 times. Okay, it will keep iterating the 5 times. It also get rid of from the AUC results and also the recall matrices and precision matrices. So obviously the precision and recall going to be high and anyhow. So we are going to be check with some of the slightly improvement with corresponding to the AOC ROC